Good morning, guys. Today we're going to talk about 1.4 measuring angles. All right. So we're going to start off with some definitions and how to name it and a diagram. Okay. So an angle is formed by two rays with the same endpoint. The rays are the sides of the angle, and the endpoint is the vertex of the angle. Okay. Now, we name it by, like if you look at the diagram, we have vertex A, so we can name it angle A. Or we can name it by a point on each ray and the vertex. So here we have B, A, C, so I can name it angle B, A, C. Or I can name it C, A, B. And the last way, I can name it by a number. And here we have the number 1, so angle 1. All right. So the sides of the angles are ray AB and ray AC. And our vertex is A. All right. When you name angles using 3 points, the vertex must go in the middle. Okay. The vertex has to go in the middle. The interior of an angle is the region containing of all the points between the two sides of the angle, and the exterior of an angle is the region containing all of the points outside of the angle, okay? So think of interior, inside, exterior, outside, all right? In part 1, we're going to name the angles. So it asks us what are 2 other names to name angle 1. Well, first thing I'm going to do is I'm going to identify what angle 1 is. And angle 1 is this angle right here. Now, remember, we can name it by a point on each ray in the vertex. But if you look right here, the vertex must go in the middle. So we can name it angle JMK and angle KMJ. All right, one way to measure the size of an angle is in degrees. To indicate the measure of an angle, write a lowercase m in front of the angle in the diagram, okay? So we would say the measure of angle A is 62, and we will write it as m, angle A is 62, okay? So right here, we're stating that 62, or angle A has a degree of 62, all right? Now let's start talking about the different types of angles, okay? Now, X here will be our degree. So if X is less or is greater than 90, but less than 180, we will have an obtuse angle, okay? So greater than 90, but less than 80, we will have an obtuse angle. When we have an angle that is equal to 90 degrees, okay, equal to 90 degrees, and we will have a right angle, okay? Now, if we have a angle that is greater than 0, but less than 90, we call it an acute angle, okay, an acute angle. And then lastly, when we have a straight line, basically, when X is equal to 180, we call it a straight angle. Angles with the same measure are congruent angles. Now, remember, when we say congruent, we are saying that they are equal, so they will have the same measure, okay? They will have the same degree. This means that if the measurement of angle A is equal to the measurement of angle B, then angle A is congruent to angle B, okay? You can mark your arrow, or you can mark your angles with arcs to show that they are congruent, all right? So part 2, all right, we're going to start talking about using congruent angles, all right? So it says synchronized swimmers form angles where their bodies as shown in the photo. If the measure of angle GHJ is 90 degrees, what is KLM? All right. So what I'm going to do first is I'm going to identify the two angles. So we have GHJ, all right, and then KLM, all right. These are the two angles that we are looking for. Now, if you see right here, we could see we have 1, 2 tick marks, okay? They are marked like this, correct? So that means that they are congruent. So if the measurement of angle GHJ is 90, then it is congruent to KLM. So the measurement of angle KLM is 90 degrees. So they are a what type of angle? A right angle. Very good. All right, second part. If ABC is 49, so ABC is 49. All right, here's our tick. What is DEF? DEF. Well, we have one tick mark, so what we're saying is that tick mark represents that these two angles are congruent. So the measurement of angle ABC is congruent to the measurement of angle DEF. So the measurement of angle DEF is in fact 49 degrees. All right? All right, now we're going to look at part 3, okay? And we're going to use the angle addition postulate, okay? Now, this is very similar to what we did in the last section when we did the segment addition postulate, all right? So let's go ahead and let's dissect what the directions are telling us, okay? So if the measurement of angle RQT, so R, I guess this is Q right here. So RQT is 155. So this whole angle right here is 155, all right? Then what are MQS? So grab another color. So this angle is RQS. And this angle is angle TQS, okay? Now, as you can tell, angles RQS and angles TQS make up angle RQT. So what we're going to have to do is we're going to have to take the measurement of angle RQS, add it to angle TQS, and set it equal to, this all should be the measurement, so the measurement is equal to the measurement of angle RQT, all right? So now I'm just going to substitute what we know in and solve for x first. So RQS is 4x minus 20 plus 3x plus 14. Set it equal to 155, okay? So we have 4x plus 3x, which is 7x. Negative 20 plus 14, negative 6. Set it equal to 155. Add 6 to both sides. So 7x is equal to 161. Divide by 7. And x is equal to 23. All right? Now, we are not done, okay? We now have to figure out what the measurement of angle RQS is and the measurement of TQS, all right? So what I'm going to do is I'm going to write down each equation again. So the measurement of RQS is equal to 4 times x minus 20, okay? And then the same thing for TQS. We have 3 times x plus 14, all right?
Good morning, students.
So 4 times 23 minus 20 is 72 degrees. And then 3 times 23 plus 14 is equal to 83. And then 72 plus 83 gives us 155. And that was the measurement of angle RQT. So I know that my math is complete. We were correct. All right? All right, in the second question, we have angle DEF is a straight angle. So that means that the measurement of angle DEF is 180 degrees, all right? And we want to find out what angle DEC is, okay? And angle CEF, all right? Now, remember that DEF is a straight angle that has a measurement of 180 degrees, okay? So what we need to do is we need to take the measurement of angle DEC, add it to the measurement of angle CEF, and set it equal to the measurement of angle DEF, all right? So DEC is 11x minus 12. CEF is 2x plus 10, and the measurement of angle DEF is 180, all right? So now all the thing we have to do here is combine our like terms. We have 11x and a 2x, so that gives me 13x. Negative 12, positive 10, we have a minus 2, set it equal to 180. Add 2 to both sides. 13x is equal to 182. Divide by 13, and x is 14, okay? Now, I'm going to move over here and find the angle measurements of DEC and CEF, all right? Now, DEC is 11x minus 12, and angle CEF is 2 times x plus 10, all right? Now, 11 times 14 minus 12 gives me 142 degrees, okay? And 2 times 14 plus 10 gives me 38 degrees. Now, 142 plus 38 is equal to 180, okay? Now, 180 is the measurement of a straight angle, and that is exactly what angle DEF is. So we know that our math is done, and it is correct.